Hi everyone. Today we are discussing about triangular functions. Today we are discussing about triangular functions. It is different compared to the sinusoidal waves and square waves. It is different compared to the sinusoidal and square waves. Sinusoidal and square waves. Triangular means the path of the or direction of the angle is lies between three major nodes, width, height, area. Width, height, area. That's why it is called triangular functions. That's why it is called triangular functions. The triangular function t of t, the triangular function t of tri of t is equals to 1 minus mod t, where mod t less than 1, 0 otherwise. That means the triangular wave varies is lies between plus 1 to minus 1, plus 1 to minus 1. Next one is sampling function and sine function. Sampling function and sine function. The sampling function SA of t can be represented as follows. The sampling function SA of t can be represented as follows. SA of t is equal to sine of t by t. Sine of t by t, where SA equal to sampling, t equal to time, sine equal to angle of the pulses. Angle of the pulses. Angle of the pulses. And the sine function, sine of t can be expressed as follows. Sine of t is equal to sine pi of x by pi x. Sine pi of x by pi x. Here the wave is lies between plus 1 to minus 2. Plus 2 to minus 2. Plus 2 to minus 2. And these are the two different formulas when we are using to simplifying the problems in several conditions and several situations. The unit impulse function or Dirac delta function. Next one is the unit impulse function or Dirac delta function. The impulse function is not a function in the ordinary sense. That means in compared to the different functions of signals, but the unit impulse function is differ or separate function compared to the other functions, since it is 0 at every point except to where it is unbounded. Laterally we are seeing the clear explanation of impulse function. Many physical phenomena such as point sources, point charges, voltage sources acting for every short time can be modulated as delta function, delta of t can be modeled as a delta function that will be represents delta of t. So this is the function of impulse, or this is a impulse function where delta of t varies 0 for t not equal to 0, infinity for t equal to 0, unbounded where infinity equal to unbounded. The mathematical expression of delta of delta of t is delta of t 0 for t not equal to 0, infinity for t equal to 0, where infinity is unbounded. Impulse function means already we are seeing the meaning. Impulse function is not a function in the ordinary sense, since it is 0 at every point. That's why it is indicates 0 when we are seeing the waveform. When we are seeing the waveform, it is a impulse response function. It is a impulse response function. It indicates 0 at every point. That is the major difference between other waves and impulse waves. That is the main difference between other waves and impulse waves. That's why it is indicates 0. That's why it is indicates 0. That's why it is indicates 0. Practical representation. Practical representation. In practical representation also, when we are seeing the step sizes of the signals A and B waves, here in this also the impulse wave is indicates 0, second diagram B, and first diagram A wave varies different impulse function blocks or areas delta by 2 to the minus delta by 2. If we take the limits t tends to 0, if we take the limits t tends to 0, we get a pulse of infinity, height 0 width, but still with an area of 1. That means height, width, area will be provided by using the value of t tends to 0. When we are using the value of t tends to limits of t tends to 0, we can easily find out the area, width, size, height, width, area. By using these are all, we can applying the t tends to value, and we can easily find out the values of height, width, area. Next one is properties of impulse function. Properties of impulse function. For example, delta of 0 is tends to infinity. Delta of t is equals to 0. Delta of 0 is equal to infinity. Delta of t equal to 0, where t not equal to 0 situations. T not equal to 0 situations. For example, Gaussian curve. When we are seeing below diagram Gaussian curve, this is the Gaussian curve. It is a Gaussian curve, and the formula for Gaussian curve is f of x equal to 1 by root of 2 pi sigma square e power x square by 2e sigma square. So 2 sigma square. That means the sigma values is lies between sigma in tends to 0, f of 0 tends to infinity, width tends to 0. That means when we are using above formula, the wave shapes are three types. One is sigma tends to 0, and sigma tends to infinity, and width is equal to 0, but the area under the same curve remains. So that means in previous triangular waves, when we are already seeing this is a triangular function. This is a triangular function. In any triangular function or waves, it will mainly use it to explain the behavior size of the signals, either width, height, or area. Either width, height, or area. By using these three elements, we can easily find out the behavior of the signal. So here in this also we are using different signals: small, medium, high signals, or Gaussian curve, which is explain the behavior of the signals with respect to time, width, height, area. With respect to width, height, area. So these are the different meanings of triangular function, sampling and sine function, unit impulse function, or Dirac delta function, and practical representations and properties of impulse function. Next class we are discussing other topics. Thank you.